Hello. This year we have studied different kind of functions. We have worked with linear functions, quadratic functions, exponential functions, and just with functions in general. In this series of videos, we are going to review what we have learned so far. And I'm going to start by talking about functions in general, even though that was not the first we studied. So, first of all, we need a definition. What do we mean by a function? By a function, we mean a rule that, given a value, performs some operations to answer with a new value. So for instance, if my variable is called x, I can perform some operation and assign the value f of x. I can do this in many ways. But for instance, talking about the examples we have seen this year, we can say, for instance, that f of x is equal to negative 3x plus 5, and that's a linear function. Or we could say, for a different function, let's say g of x is given by a half times x plus 3 times x minus 1, and that's a quadratic function. We could say that h of x is given by 100 times 0.82 to the 85 to the power of x. That's an exponential function. But of course, there are many other types of functions. Some of them, you know them. Like for instance, k of x is the square root of x, or j of x is given by 1 divided by x squared, and I could continue for a very long time giving examples of functions defined by their formula. But the important property here is that we have a value for the variable, we do something to it, and we obtain a result. And in order to call this a function, we have to make sure that any time that we assign the same value to the variable, we should be obtaining the same value for the function. So what is not a function? Let me give you an example. I'm going to give you the example by sketching a graph. So here I have x and y axis, at least on the positive side. And let's say that the graph that I sketch looks like this. This is not a function because for a given value of x, let's say 1 over here, I wouldn't know what is the corresponding value if the value over here, which will be, let's say, 3 over 2, or the value over here, which will be 1, 2, 3, 3.6. So this is not a function because given x, I don't know which y to assign. So this brings us to the test that we call the vertical line test. If we have a graph and we want to know if that graph represents a function or not, what we need to do is to draw vertical lines and see if they cut the graph at one point or more. So for instance, over here, if I start where the function starts in some sense, so with the value of x equal negative 1, or let me see, let me look better, negative 1.2, there will be one point where the ruler cuts the function only once, but then as I keep moving, I will see that any position of the ruler cuts the function at 2 points. So, for instance, 1 point over here and 1 here. So we'll say that this graph fails the vertical line test. And this means that it does not represent a function. So let's say that we agree on what the function is. Now, what are some properties that we want to study about them? Let's see. The first thing I want to mention is the domain and the range. If we have a function f that makes correspond to a value x, the value f of x, the domain of f is the set of points for which the function is defined. So it's the x belonging to the real numbers such that f of x exists. On the other hand, the range of f is the values that are reached by the function. So the y belonging to the reals such that y is f of x for some x. In a picture, let's sketch one. Let's say we have our axis here, x and y. I'm going to sketch a function. I'm going to be careful to draw something that passes the vertical line test. So I'm going to start over here. I'm going to go up for a bit, and then my function is going to go down. Okay, so let me explain a few things about this sketch. Here I'm marking this point. This is the point. Let's write the scale here. Let's say this is 1 and this is also 1. So this will be the point at -4, 1. And I'm saying that this is a point of the function. So I'm saying that f of -4 is equal to 1. So the function goes up to crossing the y-axis at the point 0, 3. And then it goes down and it crosses the x-axis at the point, let's say this is 3.5. And then it goes down, and I need to explain a little bit what this goes down means. I'm going to say that the function keeps going towards -infinity as x grows. So as x grows, the function approaches -infinity. So what I'm saying is I cannot really show this in the graph, but the function is going to be getting smaller and smaller and smaller as the values of x grow. So let's write what is the domain of this function. Let's write that this is y equals f of x. So these are the values of x such the function is defined for them. And I can see in my graph that the first value that I have my function defined for is for -4. Before -4, there is no function. And then after -4, for all the points, I have the function defined. Here we can see it with the picture. And then the clarification here says that as x grows, the function goes to -infinity. So it's still defined. So the domain of f is the x belonging to the reals such that x is greater or equal than -4. Now we look at the range of the function. So we want to see for which values the function is defined. So I'm going to look at the maximum point for the function is the point over here. Let me write this is half. And here, well, let's say this is a point 3.1. I made the function so I can decide these things. So that's the largest point that I can find in the y-axis, 3.1. But I can find any point as small as I want because it says that as x grows, the function goes to -infinity. So what does it mean? That the range is the values of y reals such that y is less or equal than 3.1. Any value less than 3.1 is going to be, or equal even, less or equal than 3.1 is going to be in the range of the function. Okay, what else can we say about this function? We mentioned the domain and the range. We can write here the axis intercepts. We can write that it has y-intercept, that's when x is equal to 0, we can see it in the picture at the point 0, 3. It has x-intercept at the point 3.50. Remember that there could be many x-intercepts. In this picture over here, there is only one, but I mean, I could change my function to make more if I wanted to. And those are my x-intercepts. We can also look at when the function is increasing or decreasing. So the function is increasing. So the function is going up for values between -4.5. So when I start here with the value of x -4, the function is growing and growing and growing up to achieving the maximum at 3.1. That's when x is a half. And then the function goes down, so it decreases. So increasing for -4 less or equal than x less or equal than half, and decreasing for x greater or equal than half. So after half, I start going down. I also mentioned that over here I have a maximum for the function at the point a half, 3.1. That's another interesting characteristic of the function. And the last thing that I want to mention is how can we use the graph function to find the value of y knowing x, or to find x knowing a value of y. So let's write here just two short examples. For instance, if x is equal to 2 from graph, f of x is equal to, let's check in the graph. So how do we do this? I need to find the point when x is equal to 2. This is here. And now I have to find the corresponding point in the function. That's here. And I need to go to the y-axis and find what is the y-coordinate of that point. And I see here it's approximately 2.4. So let's say 2.4. So that's how I use the function to find the value of f given x. Now let's say that I want to find x such that f of x is equal to 1. So I'm going to find the value y in the y-axis. Here it is. And I'm going to look for a value or many values of the function where the function takes the value 1. So I have two possibilities here. I have one going towards the left, and I have one going towards the right. The left one corresponds to x equals -4. So x can be -4. And the right one, if I go down here, corresponds to x equals to 3. So, or x equals to 3. That's another solution. So we review what a function is. We review what the domain and the range of a function mean. We saw an example given with a graph, and for that example, we looked at the domain, range, axis-intercepts, the intervals where the function is increasing or decreasing, and how to find value of f knowing x and using the graph, or how to find the value of x that corresponds to a given y, and there could be many for that case. So that's it for now.